views expressed on this program are those of the hosts, guests, and callers, and are not necessarily those of this station, its management, or other advertisers. You're listening to Transformation Talk Radio.
Welcome to Business Game Changers, where you'll hear expert tips on the big issues and the hottest trends to level up your business game. If you're building a career or building a business, this is Must Hear Radio. Here's your host, Sarah Westall.
Welcome to Business Game Changers. I'm Sarah Westall, and you're listening to Conscious Business Radio on the Transformation Talk Radio Network. And I hope you're having a wonderful day so far. And I think it's going to get a lot better for you as you listen to this interesting show that I have lined up for you. We have Dr. Bill Andrews joining us today, and he is the president and founder of the biotechnology firm Sierra Sciences. And he is widely considered one of the foremost or the foremost researcher on aging and specifically on telomeres. And he has dedicated almost his entire professional career devoted to finding a cure for aging and also researching telomeres and how to lengthen them. In fact, in 1997, his team was the team that found telomerase, which is an enzyme that actually lengthens your telomere. And it's a complicated subject, and he's going to explain the science behind all this. But essentially, every cell has a Hayflick limit, and that is the number of times a cell is able to reproduce itself. And a telomere is what indicates to your DNA or your chromosome that it is no longer able to replicate. But the enzyme that he identified allows the telomere to lengthen again, so that your cell can ultimately reproduce forever and become immortal. It's a really fascinating conversation that we have with them about how to cure aging and some interesting looks into the subject. And, we get into the science, we get into his research, we get into what the social impacts are. Obviously, if you cure aging, you're going to have some pretty big social ramifications, and people have all sorts of different opinions on this. But he is on a quest. He's on a quest to provide or come up with a safe and affordable drug that will lengthen telomeres in your entire body, in every cell in your body. And in fact, he believes that if he gets the research that he needs, he is 1 year away from conducting human trials. And this is after many, many years, decades of doing this research, and they are so close. In fact, they do have some drugs right now that works, but just not 100%. And he will talk about this today, and it's really good. I'm sure this will change the way you view aging and our future on this topic. So now we're going to welcome Dr. Bill Andrews to the program.
Hi, Bill. Welcome to the program.
I'm glad to be on.
Well, you claim to have a cure for aging. What do you think you have a cure, or what's going on with that?
Well, we definitely do not have a cure for aging.
But you're working on it.
Yes, we have an idea, and I want to say that this is not originally my idea. This is an idea I learned of back in the early 1990s, mostly from Dr. Calvin Harley. But it's research is still underway. I'm obsessed with spending my whole life trying to right now work on trying to get this figured out. It's not that we don't know what to do. I think we know exactly what to do. Our obstacle is just it's so expensive. Finding the funding to do it all is what's the obstacle. But I think we will have something to at least test in humans by at least 1 year after we get the funding that we need. Because we've already spent something like $33 million in the last since 1999, and have gotten up to about 1 year away from being able to test in humans when the global financial crisis of 2008 hit. And we've been kind of stagnated since then. But we're pretty confident we're going to get the funding pretty soon. And by the end of 2016, I think we'll have something ready to start testing in humans. And, you know, I'm looking forward to the day when we have Betty White walk out on the stage and looks 24 again.
Oh, that's crazy. So I would think that there's a lot of elderly, rich people that may be interested in funding you. That say, I'm not sure if I want to die, and they'll give you some money.
You would think so. We have a lot of such people on our mailing list that are very interested in taking the treatment when we have it developed. But since 2008, that's what everybody's been pretty much holding on to their money. A lot of, like, even billionaires are talking to us right now about trying to help us find somebody else to invest because their money's all tied up.
Oh, I suppose with everything, if you're a billionaire on paper, that's not the same thing.
Well, see, that's exactly. Everybody's billionaires on paper. And then the billionaires that, let's say, they have a lot of cash sitting in their closet and stuff like that, more than they could possibly know what to do with. They're probably out vacationing and don't even know about us. So the big obstacle is, how do we get to these people? Because I'm offering, hopefully, let's say I'm offering the potential of them being able to vacation for many, many more years, and to be young and healthy at the same time.
So you think that me or my children will potentially be able to live forever?
I think my 87-year-old father, who is suffering from Alzheimer's right now, is going to be able to be young again and have his cognitive abilities come back.
Wow. So you think you will be able to reverse, not just cure aging, reverse aging?
Yes, and pretty much that's what I typically call curing aging, is actually reversing it. So if you're suffering from old age, I consider that you're suffering from a disease. And I want to cure that. I want to get rid of all the aspects of old age and make people young and healthy, you know, dancing, playing tennis, having the time of their lives when they're 150 years old. You
mean not having the inner tube around your belly? Because your body doesn't process stuff properly anymore?
You can still have that if you want it.
I suppose you could.
I'm not offering a way to not exercise and not eat well and be able to look like have the perfect figure.
It just takes more effort as you get older, right?
And believe me, I'm experiencing that firsthand myself.
Yeah, I think we all are, except my husband, who's very slender and doesn't understand why I'm struggling not to eat that extra chocolate chip cookie. He doesn't understand it. But, okay, so Harvard was recently able to reverse the age of rats in a lab. So there's some scientists that actually made that happen in a lab with rats. Are you using the same process that they did? And
kind of.
What did they do, and what are you doing?
Well, first of all, they did it with mice, not rats.
Oh, I thought it was rats.
Yeah, and that's Dr. Rhonda Pinno, and he has since gone on to become the head of MD Anderson. So anybody who thinks that everybody working on anti-aging is quacks and charlatans, that's not true anymore. There's, maybe 99.99% of the people working on anti-aging and stuff like that are quacks and charlatans.
There's quite a bit that are.
This field is just so full of it. But there's actually now some real science going on. Now, Dr. Rhonda Pinno, what he did is he used a gene therapy technique. He actually genetically engineered mice. So he took like single mouse cells, manipulated the genes in the DNA so that he could now cause the cells to produce this enzyme called telomerase or not produce telomerase at will. And so what he did is he then engineered these cells and then took one of those cells and grew it into a mouse. You can do that with mice. That's what mouse cloning is. You take a single cell and you actually induce that to become a whole mouse. Then he bred that mouse and then bred their offspring, and then eventually he had a whole colony of these mice that he could, by feeding him a certain substance called dihydroxytamoxifen, he could cause the mouse cells, all the mouse cells, to produce this enzyme telomerase. And in the absence of feeding them this dihydroxytamoxifen, they didn't produce telomerase. So what he did is he let these mice get really old. And, they were suffering from everything that, like humans do. Their male pattern baldness, their hair was falling out, their hair was turning gray, their organs were getting smaller, their brain was getting smaller, they couldn't reproduce anymore, they couldn't walk around, they lost their sense of smell. I could go on and on. But then when they got really old, he then fed them the dihydroxytamoxifen, and very shortly thereafter, they were suddenly young again. And they could do it. They could reproduce again. They could remember how to do things like go through a maze. Their sense of smell came back. It was
It's amazing. And that had to do with the telomerase.
The enzyme telomerase. Yes, it's
telomerase. Yeah.
Telomerase. And what telomerase does is it lengthens the tips of our chromosomes, or in that case, the tips of the chromosomes in the mice. And the tips of the chromosomes are called telomeres. And it was discovered in the 1970s when people were looking at telomeres in human cells and other types of cells, that telomeres get shorter as you age. Now,
in the 70s, they realized, did they find it because I remember hearing about it in the 90s. Did they find it in the 70s and then realize in the 90s how it worked, or is it just started getting more known in the 90s?
It became, let me continue where I'm going, because I'll tell you where the change occurred. It was observed in the 70s that the telomeres get shorter, and you could actually measure the length of the telomeres and tell somebody how old they were, or more importantly, how long it would be before they die of old age. But the thing is that the analogy that people like to use was it was like a shoelace, and the telomeres, like the chromosomes, a shoelace, and the caps on your shoelaces are equivalent to the telomeres on your chromosomes. So in your shoelaces, as the caps get shorter and shorter, your shoelace starts to fall apart. And so the speculation was the same thing's happening with your chromosomes. But in the shoelaces, it's a wear and tear kind of thing. The aging of the shoelace causes the caps on your shoelaces to get shorter. So people were thinking back in the 70s that this was probably the same thing in humans, is that aging was causing our telomeres to get shorter. So what was soon realized after that, probably in the 80s, late 80s maybe, was that the telomeres don't shorten in reproductive cells. So why was that? Why was all the other cells in our body having the telomeres get shorter, but they didn't shorten in our reproductive cells? And so, by reproductive cells, I'm talking about the cells responsible for producing our sperm and our eggs. And that was important because if they did get shorter, then our children would be born with shorter telomeres than we had, on and on and on, and we would have been extinct as a species just after a few generations. So our reproductive cells don't have telomere shortening. Well,
so they're immortal. Our reproductive cells are immortal, essentially.
Yes, and that's, if you remember human embryonic stem cells, all the concern about how we get those from, not we, but scientists get those from aborted fetuses and stuff like that. They're a cell line that is essentially immortal. And they're called human embryonic stem cells. And those are the cells that actually produce our sperm and our eggs. And they also can produce every other tissue in the body, but when they do so, they start aging. So in the early 1990s, we discovered that cells like our reproductive cells produce an enzyme called telomerase. And that's why the telomeres don't get shorter. So every time the telomeres would get shorter, telomerase would just re-lengthen them. So that's what we found this enzyme. And so right after that was my team at Geron Corporation.
So you led the team that found that enzyme.
Yeah, the human form of that enzyme. And it was earlier discovered in the 1980s. Elizabeth Blackburn and Carol Greider discovered an equivalent enzyme in a pond scum organism called Tetrahymena. But they didn't put the twos and two together to realize how significant a discovery this was. And they published that in 1984, and essentially nobody did anything with it for the next 8 years until at Geron Corporation, under Dr. Calvin Harley's guidance, we went after that enzyme to see if that had anything to do with the aging process. So we discovered that enzyme, the human form of the enzyme, which turned out to be significantly different than the Tetrahymena one. So it ended up being quite an obstacle to discover that. But when we discovered it, we put it into normal human cells. And we discovered that not only did they stop aging, but their aging actually got reversed by every method of measurement you can imagine.
We need to take a quick station break, and we will return in a moment.
Tune in to The Jen Royster Show, intuitive guidance to inspire your life, each Thursday at 8 a.m. Pacific and 11 a.m. Eastern on TransformationTalkRadio.com. This amazing show is an inspirational hour that will take you on an epic metaphysical journey to discover the spiritual approach to life's greatest challenges. Dr. Jen is an internationally known intuitive counselor, spiritual teacher, and energy healer. Call in for intuitive readings and visit JenRoyster.com for more information.
Are you feeling broken from your relationships? Are you second-guessing yourself about friends, family, and lovers? Tune in to the hit show that's creating a buzz in the love-seeking community. Love Seeker Radio, finding love for your authentic self with renowned love coach Heather Lynn. Tired of dissatisfying relationships? Kiss them goodbye and power up your love seeker energy. Coach Heather Lynn reminds you that you can just be you, the beautiful and perfect you. Visit HeatherLynnCoaching.com to learn more. Tune in to Lucid Planet Radio with Dr. Kelly Neff. This hit show will illuminate your senses and empower you beyond your daily stressors and hardships. Renowned psychologist and author Dr. Kelly will captivate you with far-reaching topics and amazing guests as you wake to the greatest version of yourself. Learn to tap into your intuitions, think critically about our world, heal emotional and psychological wounds, and follow your passions to live your dreams. The Lucid Planet. Welcome home. Visit lucidplanetradio.com for more information.
And we are back. This is Sarah Westall with Business Game Changers, and we are on Conscious Business Radio. We are currently talking with Bill Andrews about how to cure aging.
So in a lab, you can take individual cells and you can reverse the aging of that and get it back to its youth.
Absolutely.
And can you do that with like an organ or parts of a human? You can't. You can only do it at an individual cell level at this point.
Well, yes and no. But let's say back then we could only do it with a individual cell because it required us inserting the gene. That's a gene therapy type technique, and we can't insert the gene into all organs. But getting back to your original thing about, when did it all take kind of all the discussion start occurring? It was when we showed that when we discovered the enzyme, we showed that we could actually reverse aging in human cells. That showed that telomere shortening wasn't a result of aging; it was the cause of aging, or a cause of aging. Let's say.
Because if you solve that problem, could there possibly be other factors in the aging besides that?
Absolutely, and I'll get back to that in a second. But the fact that we now had shown that the telomere shortening was a cause of aging, not a result of aging, that just led to tremendous news stories, lots of publications. It went from an average of probably one publication a year to hundreds of publications a year on the subject. And that's when the Nobel Prize Committee started saying somebody needs to win a Nobel Prize for this. And so Carol Greider, Jack Szostak, and Carol Greider, Elizabeth Blackburn, Carol Greider, and Jack Szostak won the Nobel Prize for their pioneering work back in the 80s and earlier with discovering the role of telomeres and discovering that enzyme telomerase in that pond scum organism.
So maybe you could have won the Nobel Prize if it was looked at for what you guys were doing.
Well, I mean, someday maybe it's not actually a goal of mine. I mean, everybody would love to win a Nobel Prize, but in fact, I'm kind of embarrassed in the fact that, like, at least I've got 7 good friends right now that have won Nobel Prizes, and 5 of them were friends before they won the Nobel Prize, including my roommate in college.
Oh, so you're all like in this competition.
So I'm the black sheep so far. Yes,
oh,
so
you are.
I better win one.
But if you cure aging, I have a feeling you will be win more than a Nobel Prize from a historical standpoint.
Yeah, it's Nobel Prizes aren't awarded exactly that way. I would be very happy to see Calvin Harley win the Nobel Prize because it was his idea, and I'm still pursuing his idea. I mean, the second I heard the idea, I was absolutely. In fact, I was at a conference in the Grand Levacan Hotel in Lake Tahoe, listening to him talk when he talked about the fact that telomeres shorten. This is the first time I learned it. Before he could even get off the stage, I was at the bottom of the steps.
Tackling him.
I want to work with you. I want to do this.
Yeah. I know what that feels like when you're passionate about something.
It was only 3 months later that we actually discovered. So I went, it was the shortest job interview ever. I went to work with him just a few weeks later, and it was only 3 months after that we had actually discovered the human telomerase enzyme. Well,
so why do you think this will actually work? And I know you described it's working in a lab, but why does it work, and why do you think this is the factor versus being other factors that people are talking about?
Let me rephrase it, because I'm not saying that it is the work. I want to answer the question: is it the factor?
Okay, that makes sense.
We have a lot of data, including Rhonda Pinnell's mouse data, but humans aren't mice. It doesn't necessarily mean it's going to work on humans. It works really well on human cells, but humans are a lot more complicated than just a single cell. So we have a lot to do. So we just need a way to be able to ask the question. And that's what we're working on, just trying to develop a pill that will get, if you swallow it, will get the ingredients will get into your blood, get into your cells, and cause the telomerase enzyme to be produced in all the cells. And then when we have that working, then we ask, does it cause human aging to be reversed?
And then if it helps, but it's not the full thing, then you can say, okay, now we know that our cells are reproducing and living. What else is causing the aging? Maybe then you could get to the other factor on top of it, right? But if you get the other factor, like let's say it's toxins or something, and toxins are also causing you to age. But if you cure toxins, but you don't cure this, then you would never know. But if you have to do this is kind of like a source problem, I would think.
Actually, you hit the nail right on the head. I do believe that there's many, many causes of aging. I believe in every theory that's ever been predicted. I'm sure they all work together. But this telomere shortening is the only one that I know of that absolutely has to be solved, because none of the other ones are going to work if telomeres are still short.
Because this is a molecular level problem. You got to solve the basic issue. It's a foundational problem. Then the other thing is about, it's like a car. Like if you're not changing the oil and you're not doing all the basics, that'll cause the car to run down as well. But if you don't change the fact that the steel is corroding because whatever, it's the same thing. It's a structural issue versus a just a maintenance problem.
Yes, and we have. I think of all these different theories on why we age as sticks of dynamite that are burning inside of all of us. Every cell in our body has let's say 20 sticks of dynamite burning all at the same time. But the big question is which stick of dynamite has the shortest fuse. And I believe that in humans, that it is our telomeres. I think that the shortening telomeres are the fuse that's burning, and it's the first fuse that goes out in, let's say, really healthy humans. Humans that live very healthy.
That eat well, exercise, do the things that we know can keep you healthier longer.
Yeah. Now, smokers and people that are obese and things like that, they'll probably never, ever die from the telomere shortening, because other things will probably kill them first. And still, it turns out that the other things can actually cause telomere shortening, like oxidative stress will cause telomere shortening at an accelerated rate. So they could still end up dying because of the telomere shortening, but it would be caused from more of a active process of actually free radicals actually cutting the telomeres and making them shorter. Whereas in a really healthy person, the reason why the telomeres shorten is because of the lack of the ability to keep them long. And let me describe that for a second. Think of a chromosome as like the top layer of bricks on a brick wall. And when a cell has to divide, it needs to make a copy of that top row of bricks. And so a bricklayer has to go along and make a new row. Well, now let's imagine that brick's so high that you can't reach up and put the bricks, so you have to stand on top of the wall. But when you get to the end of the wall, while you're making this new row of bricks, you're going to fall off and without placing the last brick, because there's no place to stand. And that's what happens in our cells. And so that's the lack of the ability to be able to make the new chromosome as long as the old chromosome. You can't make the top row of bricks as long as the previous row of bricks because there's nowhere to stand to place the last brick. And as a result, it gets shorter, and that's exactly why our telomeres get shorter. There's nothing we can do about that. I mean, it's like if you exercise or eat right or do everything your doctors tell you to do, there's no way you're going to keep that bricklayer from falling off that wall. And as a result, the telomeres get shorter. So we have to solve that problem. And the only way to solve that is through this enzyme telomerase. Telomerase actually comes in after the bricklayer falls off. Telomerase comes in and places that last brick. And when I talk about that, I usually show cartoons, and telomerase comes in as a flying angel.
That puts it in there. Now,
Yeah.
our cells do have to split and reproduce, right? In order to, it's just when we're younger, they're doing it quicker. And then as we age, they do it slower and slower, right? Until it just can't do it anymore. Is that wrong, or is that not accurate?
It's kind of wrong. It's God, I got an analogy I'll come back to in a second. The cells divide and divide and divide. They start only slowing down at the very end. A good analogy would be like, think of telomeres as ride tickets at an amusement park. Okay, so you got a bunch of tickets and you can go on all the rides you want, but when you start getting low on tickets, you start conserving. You start we don't have very many to go on. Let's really pick the best rides. So there might be a little bit of slowing down, and then when you use the last ride ticket, the ride's over.
Well, but why is it that as we age, things just don't work as well then? I thought that, as it duplicates, it's just that your cells aren't doing they're just older, what is the problem? Why is it that once you get into your 40s, you can feel like you're in your 40s?
Well, there's two things going on. One is kind of contradictory to what I just said with the ride tickets, and that is that it has been shown, especially from University of Texas Southwestern, that there are some genes in your chromosomes that express differently when the telomeres start getting shorter. So long telomeres, they'll express one way, and as the telomeres get shorter and shorter, that expression gradually changes. Okay, so that's one of the things. So there are genes, we don't know what the genes are that actually cause us to fall apart all the time, but we can speculate that some of those genes might be changing in their expression. By expression, I mean how much the gene produces of the protein. They change in their expression as the telomeres start to get shorter. That's one thing that's going on. The other thing is that the telomeres might not have anything don't do anything to the chromosomes until the telomeres get critically short. And then, so the question becomes, how many chromosomes in your cell or how many cells in your body have critically short telomeres? And so when the telomeres get critically short, then your cells start falling apart. And so that could cause like muscular dystrophy or any kind of disease where your body starts falling apart. It's just because of more cells have critically short telomeres and as a result can't function.
We need to take another short station break and be sure to come back to hear the rest of the interview with Dr. Bill Andrews.
Called the Oprah of radio by her listeners, award-winning host Dr. Pat Baccili is blowing the doors off of traditional talk radio. Get ready for an energizing delivery and powerful interviews with leaders in the field of human potential. Dr. Pat's fresh, new perspective on living life full out has catapulted her show to the top of talk radio. Tune in and Dr. Pat will help you thrive instead of merely survive. Visit thedrpatshow.com. That's THEDRPatshow.com for listening times in your area.
Holistic Medical Center is where you find it all. A healthy space with doctors who care, see, and listen to the whole you. Hi, this is Dr. Darvish. If you have not found an answer to your chronic symptoms, you will find answers here at Holistic Medical Center. Our doctors find the root cause of your symptoms and guide your body towards healing naturally. We transform lives from within. Visit drdarvish.com or call 425-451-0404.
Hi, I'm Tim Darter.
And I'm Steve Kramer.
Join us on Spirit Fire Radio. Discover how to add the mechanics of meditation to your day.
And watch yourself connect in a whole new way. Find the amazing moments in life's routines that often pass us by. Add to your awareness with Spirit Fire Radio.
Tune in each Wednesday at 9 a.m. for your weekly guide to practical mindfulness. And to learn more, visit www.spiritfireradio.com.
We are back with Dr. Bill Andrews, and we will continue our fascinating discussion.
But we think all of it ties back to that, and it depends on where it is. If your telomeres are long, then you won't see any of the aging issues we're thinking.
Right. Well, you still might after a while, but let's say if you're...
But it won't be from that. It might be from like toxins or some other buildup of some other problem.
Yeah. I just described two methods of how telomere shortening could affect the health of a cell. But if we lengthen telomeres, both those effects get negated. But you're right, you could still have cells that have critically long telomeres, and that's what mice do. Mice have telomeres long even when they die of old age, at least the non-engineered mice. Remember the Rhonda Pinto experiment was with engineered mice, but in normal mice, the telomeres stay long all the time, and mice actually die from oxidative stress and mitochondrial dysfunction.
But it's programmed to die that way, essentially, because they die about the same amount of time, right?
Yeah, but see, you can change the lifespan of a mouse a lot easier you can change the lifespan of a human. Okay, so for instance, you can provide mice with antioxidants and probably double their lifespan. Same with fruit flies, roundworms, and yeast. But that doesn't work with humans. And humans we age different. It also doesn't work with dogs.
But what else is killing the mice after the oxidative stress? Because if you're giving them anti-stress, antioxidant, why are they still dying?
We don't know everything about aging, but
come on, you're supposed to know everything.
I'll tell you, if aging research could get the funding that cancer research does, we would know all these answers. But and when I say we, I mean all my colleagues and stuff. This is a remarkably different field from cancer research and stuff like that, because the people in the anti-aging field, the really good scientists are really working on something we support each other immensely because I don't want to die of old age. I want to make certain that if I don't come up with the cure, somebody else does. So we all work together, but we still don't know everything we want to know. It's still very, very theoretical. Now, mice also age from mitochondrial dysfunction, which is where the mitochondria are falling apart. That might be a role, but there's a thing with antioxidants. You can't. It's not where if you produce a lot of antioxidants, you can get rid of all free radicals. That's going to make the mouse healthier. In fact, that will kill the mouse. You need free radicals. Okay, for instance, there's immune cells like called macrophages and neutrophils and things, and or at least some of them, where they actually shoot free radicals at invading bacteria like machine guns and kill them.
It's so amazing how we work. It really is. It must be just fascinating for you to dig into that and see that. Wow, they actually are doing them like a machine gun.
No, of course, I didn't discover that, but I was quite impressed when I learned about that. But what it says is that you have to have some free radicals. So it's always a balance. Everything comes into a green area, a red area, and a green area. Actually, does it work out? It's a red area, a green area, and a red area where you, like anything, like your potassium in your body might be too low, which would be red, just right, which would be green, or too high, which would be red. So
everything has to be in balance, right? It's like that in life.
Same is true for free radicals. You have to have some. There's such a thing as too few, and there's such a thing as too many.
Well, I would think it's the same with telomeres and telomerase, is that you can't have too many and you can't have, I bet you there's a balance to that too.
So far, there's nothing
that's showing that.
Nothing that says that there's anything wrong with telomeres too long. We've seen things, mice and human cells grown on the back of mice, the skin, where the telomeres got so long, you couldn't even measure them. Every sign was super healthy.
Critics claim that your process may create cancer because cancer cells are cells that don't die. That's the problem with them. They're immortal. And that telomerase, from what I understand, is found in those cells, which is causing those not to die. What have you found with that in your research?
Well, first, it was my team. I led the research again that demonstrated that inhibition of telomerase in cancer cells actually cause them to die of old age really quickly. And so it's got worldwide attention as the cure for cancer. And there's actually 3 different treatments right now in clinical studies, which I'm part inventor of, to treat cancer. So I'm a big believer that telomerase is something that might be a good idea to inhibit
under certain situations.
But the fact is will telomerase does that mean telomerase is the cause of cancer? And we don't know anything for certain, but I'm 99.99% certain that it's not the cause of cancer. It's just cancers want to survive just like we do. And the problem is short telomeres. Okay, so when you get a cancer and your cells start dividing, the telomeres get shorter and shorter and shorter. And then when the telomeres get critically short, the cell dies. But it dies. One of the main reasons it dies is because it starts causing all kinds of mutations. Just like when the caps on your shoelaces get short, your shoelace starts falling apart. The chromosomes do too.
So the cancer cells do end up dying, you're saying? I thought the cancer...
No, I just hadn't finished.
Oh, okay, go ahead.
So the cancers, that's what happens is the telomeres get really short and they start having all kinds of mutations, killing the cancer cells. But 1 in, let's say, 1 billion of these cancer cells will mutate to suddenly induce telomerase.
Oh, okay? And that's what the cancer is. It's otherwise they die. Your body's naturally killing it, and they're naturally dying. But with this situation, every so often some cell becomes immortal, and then that's the problem.
Yeah, now it was already cancer, but now this isn't the body fighting it. It's the short telomeres causing the cells to suddenly lose the ability to function. But that 1 in 1 billion cells then mutates to turn on telomerase, and then it solved that problem. Telomeres get a little bit longer, and then that cell grows, and that's when you get an out-of-control cancer. So it's you get an immortal cancer. All cancers are out of control, but this time now that one cell becomes cancer. The other thing is that your body does fight cancers, and that's your immune system. And when because the immune system is really good at fighting cancers, it's just that rarely cancers find ways to overcome the immune system, and one of the ways is the immune system itself actually gets really short telomeres and starts to senesce. So keeping the telomeres long in the immune cells would be something that would help to fight cancer.
So this is a very important research for a lot of other diseases as well. I mean, it's really a base foundational element for all sorts of things.
It's not just aging. It's everything. There's not a single disease that you've ever heard of that has now not been published in scientifically peer-reviewed journal articles showing that short telomeres plays a role in causing them.
Well, and I'm sure you have all sorts of researchers, or you should, that are trying to talk to you and learn what you're learning about telomeres because it has an effect on their research as well.
Yeah, oh yeah, no, they are, and they're all frustrated too by the fact that funding's not available. I'm hoping that's going to change, and we have a business model, a funding model that I think is going to fix all that. But the cancers, getting back to the cancers, it's the telomere shortening causes the cancer. So it's not so if we could keep the telomeres from getting short, then that would prevent those cells from becoming cancer, or that would prevent the cells from becoming cancer, but it'd also prevent the early stage cancer cells from actually inducing telomerase. Okay, and that we keep the immune system strong too, that would help the immune system fight the cancers. So it's actually not, telomerase doesn't cause cancer, it's the lack of telomerase that causes cancer.
So because if your immune cells are longer, have longer telomeres, then, and you keep those healthy, then the cancer will be killed off naturally by your immunity, right?
Yeah, I mean, unfortunately,
in most cases, because some cancer is pretty strong.
Yeah, the cancers are really good at coming up with mechanisms to fight off your telomeres or your immune system. But there's a lot of protocols like adoptive immune therapy right now that work really well. It's like you just identify these immune cells that recognize your cancer, and outside the body make a ton of them.
And then what? Inject yourself with those?
Inject them back in. The clinical studies are underway right now on that.
So the superhero cells come in and take care of them.
Yeah, the problem is, again, telomere shortening. And so if we could keep telomeres long, that would make that approach work. But it's right now, we won't know the answers until we actually have something that lengthens telomeres and see what happens.
So you believe, though, that you're close. Why do you think you're close?
Because we've been working since 1999. Well, let's see, I personally have been working since 1992 on this, but my company started focusing on trying to find some way of inducing telomerase to turn on since 1999. And we've been able to see, like, for instance, we found chemicals or natural products that would induce about 1% as much telomerase as we need. Then later we find something that does 3% as much telomerase as we need, and then 5, and then 10. And in late 2007, we got up to 16. Okay, and so when we extrapolate and figure out how long would it take for us to get to 100%, where we have a drug that produces 100% as much telomerase as we need, we estimated that was way under a year that we had to go. And
because you know the process now that it takes to keep increasing the percentages?
Know the rate of discovery, okay, the rate of discovering new chemicals. And now we used to initially just test chemicals at random. We tested like 300,000 different chemicals at random. The highest, most potent chemical we found scored a 5%, where it caused the cells to produce about 5% as much telomerase as they need to completely stop telomere shortening.
Unfortunately, we need to take another station break, and we will be back in a moment.
Called the Oprah of radio by her listeners, award-winning host Dr. Pat Baccili is blowing the doors off of traditional talk radio. Get ready for an energizing delivery and powerful interviews with leaders in the field of human potential. Dr. Pat's fresh, new perspective on living life full out has catapulted her show to the top of talk radio. Tune in and Dr. Pat will help you thrive instead of merely survive. Visit thedrpatshow.com. That's THEDRPatShow.com for listening times in your area.
Holistic Medical Center is where you find it all. A healthy space with doctors who care, see, and listen to the whole you. Hi, this is Dr. Darvish. If you have not found an answer to your chronic symptoms, you will find answers here at Holistic Medical Center. Our doctors find the root cause of your symptoms and guide your body towards healing naturally. We transform lives from within. Visit drdarvish.com or call 425-451-0404.
Hi, I'm Tim Darter.
And I'm Steve Kramer.
Join us on Spirit Fire Radio. Discover how to add the mechanics of meditation to your day.
And watch yourself connect in a whole new way. Find the amazing moments in life's routines that often pass us by. Add to your awareness with Spirit Fire Radio.
Tune in each Wednesday at 9 a.m. for your weekly guide to practical mindfulness. And to learn more, visit www.spiritfireradio.com.
We are back. This is Sarah Westall with Business Game Changers, and we are talking with Dr. Bill Andrews.
Then we started doing what's non-random. We call that medicinal chemistry, where we actually now, from everything we learned from all these first chemicals, we started designing new chemicals. And we in like 2 months, went from 5% to 16%. And our medicinal chemist said, boy, we haven't even scratched the surface. We got so many ideas on how to make this even more potent. And some of our first 5% ones were actually toxic in other ways, but not so toxic that they killed the cells, but slowed the growth down. We actually got rid of that toxicity too.
So now, with what you have available at the 16%, can people take that and it sort of help you? I mean, it helps you a little bit?
Yeah, it would require clinical studies to be done and things like that. Now, my company just does research. We don't do any marketing or anything like that, but a company in New Zealand did license that one chemical. Actually, there were like 5 different chemicals we found that scored between 15 and 16, but the best one was something called C0314818. It was given that name because that was the 314,818th chemical we tested. But they put that into a skin cream. They licensed that from us 5 years ago. They did put it into a skin cream, did clinical studies with a lab in Italy called Abbott Laboratories. It worked extremely well. In fact,
on people's skin?
Oh, yeah.
On their face?
Yeah, face and hands and things like that. Even though it only scored a 16%, it still was showing some age reversal. The lab in Italy said they'd never seen anything like it. That's now on the market, and I'll come back because that's part of our funding model. That's on the market in New Zealand and Australia. And if people want to learn more about it, they can go to www.TAM, that's Tom Apple Mary, 818.com.
You got to get me one of those so I can test it out on myself.
Well, I'm looking for a bottle of it right here. I don't have any nearby, but it is working really well, better than I expected. We have theories as to why it's working better, and the short answer is that even though it's weak levels of telomerase, not weak, but only 16,
sure,
telomerase does preferentially elongate the shortest telomeres. And so,
they do the shortest ones first, so it goes in and deals with the problem areas first.
Yeah.
Now, is that a very expensive product for people?
Yeah, yes and no. I mean, it's like for a 3 months supply, I think it's something like maybe $70 a month to be taking the product. You'd have to go to www.tam818.com. Because again, I don't get into the marketing. I just research.
Sure, you're a researcher.
Yeah, our goal is to develop something that's
for aging. That's just a side thing, and it's great that it's working. But your deal is curing aging, and that's what your life mission has been. But now I got to get into this potentially serious side effects. If you're successful, and you can do something, and right now that's a cosmetic thing, and I sure would like to have something that makes my skin look great forever. But the other serious side effects are namely like overpopulation, scarce resources, those kinds of things. Now let's say we get to a point where we can cure aging. Who's going to get this? Just the wealthy, and then let's let the poor people die off? I mean, there's already talk about scarce resources and people wanting, to reduce population because there's a problem with resources. How, what is this going to cause? You knew I was going to bring this up.
Yes, I'm going to make a big mess out of things. That's a fact. And my goal is to make everybody in the world happier, healthier, things like that. I don't want to see an expensive drug that nobody can afford. But most drugs, almost all the drugs on the market today are expensive because people can make more money selling them that way. And that's one of the reasons why
it's a business, right? It's all about business model, because the actual hardcore cost of producing and manufacturing it isn't that high. It's about what they can make, what maybe it costs them to create it in the first place, and then how much money they need to invest in research projects like yours.
And most of the cost of any chemical is the advertising, the packaging.
I'm sure, yes.
Getting doctors their share cut when they prescribe it to people. That's where it all comes down to. But the fact is that's one of the reasons since the very first day of this company, I've made every effort to avoid getting investors that were seeking money. And the good thing is my investors that I had they were never interested in the money. They just wanted a cure for their own aging. And so before 2008, I had no problems finding investors like that. It's been since 2008 that I haven't been able to find.
Well, it has to be some kind of pure motive, and even with the pure motive, it could get really ugly. But without it, it will for sure, because they're gonna think how much you can charge for something like that. It's just what will people spend with their life savings to cure cancer in their loved one? Everything they have, right? So now whoever owns that. It would be very ugly, and I could see the evil people trying to reduce population and all sorts of. It would be awful.
That's right, and I hope we can just drop it from planes and give it to people. Okay, I don't think that's going to actually be possible because it's going to cost money to produce it. But I can't see any reason why it should cost more than 10 cents per person, maybe $1 per person.
But
yeah, go ahead.
I was going to say, but you know what it does? It points to the fact that we have problems that we should start solving that's bigger than, like, where are we going to find more resources? Maybe we shouldn't have stopped funding NASA. Maybe we should be looking at, how do we expand our ability to use this planet? Things like that. We maybe should be looking at solving other problems so that when we can live longer, we have the resources and the means to do so.
I hope we never stop NASA. I mean, I like NASA.
Well, I know, but they've reduced their funding quite a bit, as you know.
I would like to see them get more funding, but I don't think it's going to be the funding needed to get aging cured is not that astronomical. So I don't think it's going to have that big an impact on other things. And if we do live longer, yeah, there's going to be different things that are going to have happen, but like overpopulation is something that people worry about. And I know that overpopulation is not something that needs to be worried about. For the history of time, every human race or every human population or every animal population has been shown that when they start reaching overpopulation, they reduce their birth rate.
Yeah, right? But with us, is it going to reduce the birth rate simply because certain people won't have the resources to eat, and they, you know, we'll have evil people that make it so that certain people can't reproduce, and, you know, I mean, there could be some really ugly ways that we...
There's been all kinds of things in the history of the world where this is, things you just described has already happened.
Oh, it can get ugly, yeah.
Yeah, no, it's, who knows, but here's the bottom line. Well, let me, before I go to the bottom line, just say the big concern I have is not overpopulation and things like that. My concern is if the old never get weak and feeble and therefore have to retire, they'll keep their jobs, and how will the young ever compete? How will they ever get in the job market if the old never retire?
Yeah, because they're always going to have seniority.
Yeah.
Like forever. You will always be older than me. It's like my sister. You're always older than me. And so that's not fair. I remember always having that argument when I was little.
The difference is that I will actually be younger than you by a while. Okay? But I will be more experienced, more mature, and things like that because I've been on this planet longer.
And unfortunately, we do not have time to air this entire interview. So if you want to hear the rest of my interview with Dr. Bill Andrews, which is quite a bit, I only was able to air about half of his interview today. But if you want to hear the rest, go to my website at sarahwestall.com, S-A-R-A-H, Westall, W-E-S-T-A-L-L.com. And you will be able to see the full, or hear the full interview that I have with him, as well as see all my past episodes. So for now, everyone have a wonderful day.